In this video, we'll be learning about different properties that limits have. Just like the real number system has mathematical properties, limits do too. Let's assume that the limit as x approaches a of f of x and the limit as x approaches a of g of x exist, and that c is any constant. The following properties can now be used to help us compute limits. So there are in total 9 rules that we're going to take a look at. And it looks overwhelming at first at all of these rules, but you're going to see as we go through the problems that they are pretty simple to actually apply. The constant rule says the limit as x approaches a of k, any constant, is equal to k. The identity rule, the limit as x approaches a of x is equal to a. The coefficient rule, here's one of the rules we're going to see frequently. It's the limit as x approaches a of c times f of x. Notice c is the coefficient of the function. And that's basically equal to c times the limit as x approaches a of f of x. It's almost like we're pulling that c, that coefficient, out in front. The sum or difference rule. The limit as x approaches a of f of x plus or minus g of x, this could be for addition or subtraction, is equal to the limit as x approaches a of f of x plus or minus, whichever the problem has, the limit as x approaches a of g of x. The product rule, very similar to that. It's almost like we're distributing. This is how I look at all of these. It's like we're distributing the limit across whatever's happening to the functions, whether it's addition, subtraction, multiplication with the product rule, or division with the quotient rule. Okay, so again, I think about those all as the distributive property. The power rule. The limit of f of x to the nth power is basically equal to the limit as x approaches a of f of x, all of that to the nth power. Composite functions is when one function is substituted into another. So the limit as x approaches a of f of g of x is equal to f of the limit as x approaches a of g of x. And finally, we have our root rule, where we could think about this similar to the power rule as well. Basically, we're going to take the nth root of the whole entire limit. So again, I know all the rules seem quite overwhelming, but you'll see how we apply them to problems relatively quickly. All right, let's take a look at 2 different types of problems. One is going to give us 3 limits, and we're going to ask to apply them. And then one, we're going to be given some graphs. All right, so we know that the limit as x approaches f of x is 2. The limit as x approaches a of g of x is -1. And the limit as x approaches a of h of x is equal to 8. We're going to find each limit, and we're going to identify what property or properties we use to do so. All right, for a, we want the limit as x approaches a of f of x plus g of x. This is going to be using our sum rule. So this is equivalent to the limit as x approaches a of f of x plus the limit as x approaches a of g of x. Again, that's our sum rule from the previous slide. Well, we know this first limit is equal to 2. We know the second limit is equal to -1, and add them up, and our answer is just 1. Okay, so again, we can see that we're just kind of doing a little substitution and rewriting here, and then actually computing the limit at the end is generally quick. All right, B. The limit as x approaches a of 2 times f of x. Notice 2 is the coefficient here. So this is going to be using the coefficient rule. So this is equal to 2 times the limit as x approaches a of f of x. We know that that is 2. So 2 times 2 gives us 4. All right, for C, notice something a little bit different here. So in A and B, they dealt with either f of x or g of x. In this next example, notice there's no actual function. This is an example of our identity rule from the previous page. So the identity rule says the limit as x approaches a of x is simply equal to a. All right, D looks like a little bit of a combination here. So I notice there's multiplication. So that leads me to say, well, product rule. But I also notice that there's this coefficient of 4 here. So I'm going to pay attention to that too, and I'm going to apply both of them. So the product rule, think about it. Remember, I was distributing that limit across. And then I can rewrite this one more time because I'm going to deal with the coefficient of 4. And now I can substitute in. Oops, and these are h's here, so let me fix that. So the limit as x approaches a of g of x, we know that that's -1 times 4. The limit as x approaches a of h of x, remember I'm just stealing those answers from up here, is 8. And we are going to get -32 as our answer. All right, finally for our last question here, 1E. This is going to be, we see that radical there, so we're taking the cube root, and that's called the root rule. And that's basically equivalent to when you take the, in this case, the cube root of the limit as x approaches a of h of x. Well, that was equivalent to 8, so we're looking for the cube root of 8, and that is 2. Okay, so I'll zoom out so we can take a look at those again, but we're rewriting using one of the rules, and then we're substituting. Now, when we take a look at question 2, the difference is we are not forwardly given, explicitly given, the limit is this, the limit is that. We have to actually find it from our graphs. So you'll see it might take an extra step or two to go about it. All right, so let's take a look at A. We're going to do the same idea, though. We're going to find the limits and identify what property or properties we used. All right, if we look at A, the limit as x approaches -2 of f of x over g of x. This is going to be our quotient rule because we have division. And so this is equivalent to the limit as x approaches -2 of f of x over the limit, remember it's like we're distributing here, as x approaches -2 of g of x. And now we have to find those answers to calculate it. So looking at f of x, the limit as x approaches -2, okay, that appears to be +4. Okay, right in here. For g of x, the limit as x approaches -2. Okay, so here's -2. That appears to be 1. Remember, our left hand and right hand limits must approach the same value. They must be equal for that general limit to exist. So that's 1. 4 over 1 gives us 4. All right, for B, the limit as x approaches 0 of g of x squared. So we have this to the second power here, so that's called our power rule. And that's equivalent to the limit as x approaches 0 of g of x squared. So we're going to find the limit and then square it. So we're only looking at g of x here, and we're looking as x approaches 0. Okay, so here's 0. Notice our limit is -4. We're approaching -4 from the left and from the right. Therefore, that limit is -4. Okay, when I substitute in here, this is -4 squared, or we're going to get 16 as our answer for 2B. All right, for C, I notice the subtraction symbol, so that tells me difference rule. But I also notice this coefficient of 2, so I'm going to be using the coefficient rule as well. So first I'm going to deal with the difference rule part, and I'm going to basically distribute that limit across using our rule from the previous page. So the limit as x approaches 1 from the left of 2 times f of x minus the limit as x approaches 1 from the left of g of x. Now I'm going to deal with the 2 there, and I'm going to pull that out in front. And now we're going to find these values. So we need to find 2 things here. We have to find the limit as x approaches 1 from the left of f of x, and the limit as x approaches 1 from the left of g of x. When we look at f of x here, that's our parabola, the x squared. When I approach 1 from the left, wouldn't matter if it was left or right, by the way, but we're going to get 1. So this is going to bring down the 2 times 1. And now we want the limit as x approaches 1 from the left of g of x. So let's erase these markings from before. And here's 1. As I am approaching from the left, I'm approaching -2. So we have 2 times 1 minus -2. And that's really going to be +2, and that would be 4. All right, finally for our last example, we have our composite function rule. So what we're going to do, let me write that first. This is our composite rule. All right, so what we're going to do for this one is we are going to basically think about it almost in a way like you're not distributing, you're pulling that f out. Remember, a composite function is one where one function is basically plugged in or substituted in for another. So we're going to kind of like reverse that property here, okay? So this is going to be equal to f of the limit as x approaches c of g of x, or x approaches 3 of g of x, excuse me. So when I find that value, the limit as x approaches 3, here's my graph of g of x. The limit as x approaches 3 is -5. I can see we're approaching -5 on both ways here. So we're looking for f of -5. That I can find on my graph here, or I can attempt to find it. Since I see that I have a function x squared here, if I plug that in, that's going to be -5 squared, or we're going to get 25 there for our last example. Okay. You can find other limit videos in the rest of this playlist, including how to find limits from graphs and algebraically.